Hello students, today we will see the next topic is TCP/IP reference model, a research network which was developed by US Department of Defense and connected with hundreds of universities and government installations using the lease lines. When satellite and radio networks were added to this network, compatibility issues arises. That's why the existing protocol are not compatible with the new network. So no communications in between old and new network. A new architecture is needed which connects multiple networks in a seamless way. A flexible architecture was needed since applications with diverse requirements were envisions and ranging from transferring files to real-time speech transmission, and this architecture was developed and known as the TCP/IP reference model. TCP/IP stands for Transmission Control Protocol and IP stands for Internet Protocol. This TCP/IP model is also called as Internet Reference Model. That means TCP/IP having another name is Internet Reference Model. The TCP/IP is a set of protocols or a protocol suite that defines how all transmissions are exchanged across the internet. This is called as the TCP/IP protocols. Then a TCP/IP models contains four layers. First is host network layer, second is internet layer, third is transport layer, and fourth is application layer. See this figure, and these are the layers of TCP/IP model: host to network, then internet, then transport, and fourth is application layer. Then first is host to network layer. The host to network layer is the first layer of four layer TCP/IP model. Then a host to network layer is the combinations of physical layer and data link layer defined in the OSI reference model, and it defines how the data should be sent physically through the network, and this layer is mainly responsible for the transmission of data between two devices on the same network. This is the main difference between other layers. This layer is mainly responsible for the transmission of the data between two devices on the same network. And the functions carried out by this layer are encapsulating the IP datagrams into frames transmitted by the network and mapping of IP addresses into the physical addresses. This host to network layer defines details of how data is actually sent through the network, including how bits are electrically or optically signaled by hardware devices that interface directly with a network medium. Then what is the network medium? Such as coaxial cable, optical fibers, or some twisted pair, copper wires, etc. The protocol included in host to network layers like Ethernet, token rings, FDDI, X.25, framed relay, etc. Then second layer of TCP/IP reference model is internet layer. The internet layer is the second layer of four layer TCP/IP model, and internet layer pack data into data packages, so it is known as the IP datagrams, and which contains source and destination address. That means logical address or IP address information that is used to forward the datagrams between host and across the network. The internet layer is also responsible for routing of IP datagrams. Then main job of the internet layer is to allow host to insert packets into any network and have them to deliver independently to the destinations. The main responsibility of internet layer is to send the packets from any network and they arrives the destination irrespective of the route they take. And this internet layer is also known as network layer. The main protocol includes the internet layers are IP, that means internet protocol, then ICMP, internet control message protocol, ARP, addressing resolution protocols, RARP, that means reverse ARP, and IGMP, that means internet group management protocols. Then IP protocols. IP protocol is used in this layer and it is the most significant part of the entire TCP/IP suite. And this IP provides barebone transmissions functions that free the users to add only those facilities necessary for a given applications and thereby allows the maximum efficiency. Then the third layer of TCP/IP reference model is transport layer. The transport layer is the third layer of TCP/IP model. The transport layer is responsible for reliability, flow control and correction of data which is being sent over the network. Two protocols used in the transport layers are user datagram protocol and transmission control protocol. Transmission control protocols, that means TCP. TCP is reliable connection oriented protocols that allows data from one machine to be delivered without error to any other machine over the internet. That means it breaks the data into smaller units and these smaller units is also called as a segments and which are encapsulated within the some IP packets and it transmitted. And the receiving TCP reassemble these into a single stream and gives it applications layer. This also handles the flow control. Then second is UDP, that means user datagram protocols. UDP is unreliable and it is connectionless protocol for applications that do not want TCP reliability and it is widely used for client server type request response data communications where prompt delivery is more important than the accurate delivery. Then last layer is application layer. An application layer is the topmost layer in the TCP/IP model and it is responsible for handling high level protocol issues of representations. And these layers defines the TCP/IP application protocol and how host programs interface with transport layer services to use the network. And this layer is also allows the user to interact with the applications. When one application layer protocols want to communicate with another application layer and it forward its data to the transport layer, and application layer includes all the higher level protocols, that means higher layer protocols like DNS, domains name system, HTTP, hypertext transfer protocol, then telnet, SSH, then FTP, file transfer protocols, then SMTP, simple mail transfer protocol, etc. These are the four layers of TCP/IP reference model. Then next concept is TCP/IP protocol suite. The TCP/IP protocol suite was developed prior to the OSI model and therefore the layers in the TCP/IP protocol suite do not exactly match those in the OSI model. That means the original TCP/IP protocol suite was defined as having four layers. That means we have already seen host to network, internet, transport and applications. However, when TCP/IP is compared to the OSI model, we can say that host to network layer is equivalent to the combination of physical layer and data link layers. The internet layer is equivalent to the network layer and application layer, is roughly doing the job of session layer, presentation layer and application layer, which the transport layer in TCP/IP taking care of the part to the duties of session layer. So in this section we assume that The TCP/IP protocol suite is made up of 5 layers. That means physical layer, data link layer, network layer, then transport layer and application layer. The first 4 layer provides physical standard, network interface, internetworking and transport function that correspond to the first 4 layer of OSI model, and the 3 topmost layer in the OSI model however represent in TCP/IP by a single layer called as the application layer as shown in this figure, and it having some applications shown in these figures. Like these are the protocols SMTP, FTP, HTTP, DNS, SNMP, Telnet, etc. Then it having some transport layers having SCTP, TCP and UDP, and network, that means internet layer contains ICMP, IGMP, RARP and ARP, and then data link layer and physical layer, it controls protocols and it is defined by the underlying networks, that means host to network. Then TCP/IP is a hierarchical protocol made up of interactive modules which specific functionality, and these modules are not interdependent, and the OSI model every layer is having predefined function, and the layer in TCP/IP protocol suite contains relatively independent protocols that can be mixed and matched depending on the needs of the system. Therefore, every upper layer protocols is supported by one or more lower level protocols. These are the TCP/IP and OSI models, or these are the TCP/IP protocol suite. Then comparison between OSI model and TCP/IP model. The OSI and TCP/IP reference models have many things common, we have already seen, and both are based on the concept of stack of independent protocol, and it having some functionalities of layer are almost same, and the layers have some about transport or applications oriented user of the transport services, but it having some fundamental similarities and two models having some differences. So we will see one by one. First is a TCP/IP and then second is OSI model. TCP/IP implementations of OSI model, and it is the reference model. Then TCP/IP model around which internet is developed, and it is the theoretical model. Then it has only 4 layer and it having 7 layers. Then TCP/IP consider more reliable, and it is the consider as a reference tools. Then its protocols are not strictly defined, and it strictly boundaries for the protocols. Then TCP/IP having horizontal approach, and OSI model having vertical approach. Then TCP/IP combines the session layer and presentation layer in the applications layer, and then in the OSI model it having separate layers like session layer and presentation layer. Then protocols were developed first and then the model was developed, and in the OSI model was developed before the development of protocols. Then supports only connectionless communications in the network layer, and it supports connectionless as well as connection oriented communications in the network layer. And this TCP/IP protocol is a dependent standard, and in OSI model protocols is independent standards. These are the differences between TCP/IP and OSI model. Then next concept is addressing. Addressing, a network address is an unique identifier for a node of a computer network, and addressing is the mechanism for identifying sender and receiver on the computer network. Addressing is the one of the mechanism and which is useful for identifying sender and receivers on the computer network, that means the node of computer network. And TCP/IP protocol suite uses 4 different type of addresses. Like first is physical addresses, that means link, and its functions of data link layer. Then second is logical address, that means IP, and functions, this is the function of network layer. Then third is port address, functions of transport layer, and last is specific address supported by application layer. Each address is related to a specific layer in the TCP/IP architectures. Then relationship between layers and address in a TCP/IP. First is physical layer, underlying physical network, and here this is the physical addresses. The physical address also known as a link address, and its address of node is defined by LAN and WAN, local area network and wide area network. The data link layer includes these addresses into data frames, and physical address is used when source and destinations are from same network, and it is the lowest level address. The physical address have authority over the internet, like LAN network, WAN network, etc., and the address size and format depend on the network. For example, Ethernet uses 6 bytes, that means 48 bit physical address, which is imported on the network interface card, that means LAN card. Here the physical address have authority over the network, that means LAN or WAN, and the address size and format depends on the network. Here one of the example over here, this node physical address 10 send a frame to a node with a physical address 87. See this figure, and the two nodes are connected by a link, that means bus topology LAN. At the data link layer, this frame contains physical link addresses in the header, and these are only addresses needed. The rest of header contains other information needed at this level, and the trailer usually contains extra bits needed for the error detections. The computer with physical address 10 is the sender, and the computer with physical address 87 is the receiver, as shown in this figure. The data link layer at the sender receives the data from an upper layer, and it encapsulates the data in a frame, adding a header and a trailer. And header, among other pieces of information, carries a receiver and sender physical addresses. And we have shown bus topology is isolated LAN. In bus topology, frame is propagated in both directions, left and right. The frame propagated to the left dies when it reaches the end of cable if the cable end is terminated appropriately, and the frame propagated to the right is sent to every stations on the network, and each stations which with the physical address other than 87 drops the frame because the destination address in the frame does not match its own physical address, and the intended destination's computer however find a match between destination address in the frame and its own physical address. This framework is checked and header and trailer are dropped, and the data part is de-encapsulated and delivered to the upper level. That means most local area network uses 48, that means 6 byte address written as a 12 hexadecimal digit. Every byte 2 hexadecimal digit is separated by a colon, as some example like 0.07 colon 01 02 etc. Then second addressing type is logical addresses, that means IP addresses. When source and destinations are from different network or in on internetworking environments, physical addresses are not adequate when different networks can have different address format. Then a unique universal addressing system is needed in which every computer can be identified uniquely. And regardless of underlying physical network, the logical address are designed for this purpose. A logical address in a network model are necessary for universal communications that are independent of underlying physical networks. That means a logical address can uniquely define a host connected to the internet. And there is no two publicly addressed and visible host on the internet can having same IP address, and logical address are necessary for some universal communications. See this figure, it is having one of the sender, shows a part of internet which two routers connecting three LANs, LAN 1, LAN 2 and LAN 3. Each devices, that means nodes like a computer or router, has a pair of addresses like logical and physical addresses for each connection. In this case, each computer is connected to only one link and therefore has only one pair of addresses. Each router, however, is connected to three network model. For this reason, each router has a three pairs of addresses, one for each connection. Although it may obviously, a router must have separate physical address for each connection, and it may not be obviously why it needs a logical address for each connection. And third is port addresses. The IP address and physical address in a network models are necessary for a quantity of data to travel from a source host to the destination host. However, arise at the destination host is not the final objective of data communications on the internet. A system that sends nothing but data from one computer to another is not complete. So today computers are devices that can run multiple processes at the same time, and the end objective of internet communication is a process communicating with another processes. That means a port address is a TCP IP network model is 16-bit. See these figures, here computer A can communicate with computer C by using telnet, and at the same time computer A communicate with computer B by using the file transfer protocol, that means FTP. For these processes to receive data simultaneously, we need a method to label the different processes. In other words, they need some addresses. In TCP/IP network model architectures, the label assigned to a process is called as the port address. And the port address in TCP/IP network model is a 16-bit length. And for example, J port address, 16-bit address represented by one decimal number, like 7, for example 753, and the two computers are communicating via internet are shown in this figure, and the sender is running three processes which port addresses A, B and C. See this figure. And the receiver is running two processes with port addresses J and K, and processes A want to communicate with the processes J, and the both computers are using the same application. Processes A, data must be delivered to the processes J and not to the K. For this, transport layer encapsulates the data from application layer in a packets and adds two port addresses A and J as a source port and destination port addresses. These packets is then given to the network layer, which add logical addresses like here computer A and receiver B. here A sender and P is the receiver. And the data link layer adds physical address of the next hop, and although physical addresses change from hop to hop and logical to port and addresses remains the same. Then the specific addresses, last one is address are user friendly addresses, and this is also called as the specific addresses. And some applications use friendly addresses that are designed for the some specific addresses, for example email address, URL, etc. For example, some examples of the college website or any email ID, these are the specific addresses. Here we have seen the types of some addresses, or four types of addresses. First is physical address, second is logical address, third is port address, and last one is a specific address.